Welcome to a lesson with Dr. Powell. Let's talk about what it means to find the foci of an ellipse. Imagine an elliptical ceiling. A focus, there's two foci. This is just like one half of an ellipse. And they're spaced in such a way such that if we say something and the sound waves go that direction, guess what's going to happen? They're going to go right to there. Even if we go in this direction, it's going to go right to the other focus. Even if we go in that direction, or we speak in that direction, it goes right to that focus. We speak in this direction, it goes right to that focus. In other words, sound quality is amazing because the sound coming from here in all these directions ends up focusing right over to this focus over here. So understanding where these foci are have various applications. So let's discuss how to find such a focus. It comes from a basic idea that an ellipse can be formed simply by taking two pins or nails and a string that's pulled tight. And suppose you have a string pulled tight, maybe from here to here, and you have a pencil here, and you just keep dragging the pencil around. And what happens is better than what I'm showing right here. An ellipse is traced out. Let's look at what happens when the pencil is right in between both of these. And taut means tight, so we're pulling the string tight here. So what happens now is we have our string, and it's pulled in this direction, and we have a nice kind of triangular type thing, where this distance right here is 1/2 of the total string length. Let's look at another case. When we pull the string all the way over here to this side, and it's also and then it comes back to this focus right here, so it's straight like this. How long is this string? Well, the string goes from all the way from here to here, plus this little bit. But isn't this little bit the same amount as what we'd have over here if we had the ellipse going from there to there? These are like the vertices of the ellipse right here. This line that we've drawn sometimes is called the major axis of the ellipse, and this, and kind of going up and down this way, is sometimes called the minor axis of the ellipse. The distance from here to here, if we knew what that distance was, and let's suppose that we did, let's suppose we have something like x squared, x squared over 4 plus y squared over 25, so that it looks like from here to here in our box, we'd be going 5 that way, 5 that way. So it looks like the whole string all the way across would be 10. Since we're going from here to here and then back to here. But if we cut the string right there and lifted it up and placed it here, the whole string is worth 10. Now the whole string is also positioned here from this nail going up there to the pencil and then back. And we know that this is exactly 1/2 the string. So guess how long this is? Well, the whole string is 10, so 1/2 is just be 5. So 5 is the same as this. So literally, let's look at the situation right here. We can draw a line from here to here. This distance right here is 5, and this distance is also 5. It's kind of like you're taking this and this piece right here, lifting it up in the air and moving it so that this part goes up to here, and then you're just placing it down. And where it lands right here, that is the focus. So to compute where the focus lands is simply to take this length of 5 and raise it up like a hypotenuse right here. You know what this length is from this equation. That's equal to 1. It would be a 2. So your only question is, what is this length? We use the Pythagorean theorem. Let's call this C. That's often used. Now, true, oftentimes C is used in the Pythagorean theorem as a hypotenuse length. However, C is usually the distance from the center. to the focus here. And so instead of thinking about a squared plus b squared is equal to c squared, perhaps we can just think leg squared plus leg squared is equal to hypotenuse squared, thinking of ideas. So we have 2 squared plus c squared, which is this distance from the center to the focus, is equal to 5 squared. Then we can solve for c. So this side we have 25. We can subtract 4 from both sides since this is 4. So 25 minus 4 would be equal to c squared. This right here is 21. So c is equal to the square root of 21. So that means that the focus right here is square root of 21 over this way and square root of 21 over that way. Our center, in this case, is 0, 0. To get to the focus, we simply just, to the x coordinate, that is, we add square root of 21, or we subtract square root of 21 from 0, and we get this. So these are the points of the 2 coordinate points of the foci of an ellipse. Thanks for watching.